The title of the seminar is Chatting Devices, an introduction to networking and communication protocols for use with HVAC and building automation controls. I am the presenter, Jon Vietti, and I am the owner of DDC Support Services. The seminar is going to be split into two parts, approximately 40 minutes each. Before we begin, I want to introduce you to our sponsor. So here's a brief message from the folks at iConnect Training. So let's get started with a little bit of an introduction and an overview to part one. Who am I and what do I do for a living? Again, my name is Jon Vietti and I am the owner of DDC Support Services. I've been involved in the electrical, HVAC, and industrial process controls industry for probably over 35 years now. And the primary purpose of my business is to help support the technical community. We do everything from working with design build mechanical engineers on developing their controls submittals and controls design to developing training simulators, DDC and building automation training simulators and curriculum such as is marketed by iConnect Training. Also do individual technician training and group training as well. My wife and I have 3 grown sons. We are blessed to live in the Pacific Northwest. As you can see from the picture, I thoroughly enjoy hiking and backpacking. And in one of the pictures here, I am on Mount Hood, and I am as far as you can hike up on the mountain and actually stay on a trail. It's called the Cooper Spur Trail. To the right of me is the Elliott Glacier, and that's the summit of Mount Hood. We live up the Columbia Gorge, about 2 hours east of Portland, Oregon. And the lower right picture is another view of Mount Hood out of my front window. So what are we here to discover? Basically, we can boil it down to 2 words. We're here to learn about communications and networking. In part 1, we're going to talk about how people talk to devices, or H2M, human to machine communication. And then in part 2, we're going to spend some time looking at how devices talk to each other, or M2M, machine-to-machine communication, or another term that you hear quite a bit is IoT, which stands for the Internet of Things. Interestingly enough, several years ago, I worked in a critical access hospital, and I worked for 5 years there. And at the beginning of my time there, about the only devices that were connected to the Ethernet and connected to the internet were computers and printers. By the time I finished up there in a 5-year period, almost all of the equipment, especially the medical equipment, including things like the patient beds, were connected and networked and communicating either wirelessly or through hardwired connections. So we're seeing more and more of a demand in the industry for all of these various different devices to be talking to each other and connected. So it's all about communication. Now, a couple of initial things here. I want to issue a warning, and that is that we are going to be exposed to potentially harmful levels of technology. Every time I do a presentation, there's some kind of a technical glitch, either with the software or with the hardware, or the battery goes out on my pointer, whatever it is. So just understand that through the process of this seminar, things could go wrong, but that's okay. We'll get through it. The other thing is that the IT industry seems to really love acronyms and abbreviations. So if you are averse to that, you might want to take some time to take some antihistamine or whatever you need to do to be able to endure that, because unfortunately that's the reality of the industry right now. Lots of acronyms and abbreviations. So I do want to let you know up front that this presentation is not extremely detailed. We don't go into minute detail. So if you're a computer geek, this isn't gonna fill your bill for you. It's not geek approved. I am not claiming to be an IT expert, but like many of you, I'm having to do more and more IT, or at least familiarize myself with IT work. And the goal here is, again, it's an introduction. And so my goal is to keep it as simple as possible. We will have to go in depth on a few things, but not too terribly deep. We're going to open the hood, as it were, on the car, but we're not going to pull the heads and pull the carburetor apart. I love to use analogies because I find that analogies are an excellent teaching tool. For instance, one of the best ways to teach electrical theory is something that you can't see, something that you can't feel or touch unless you get shocked, is water or hydrology. So the principles that occur in water and teaching water dynamics also occur in electricity. But I have to be careful with analogies in that if you take an analogy too far, it tends to break down and breaks. And finally, no emojis were killed or injured in the production of this PowerPoint. That's for all of you emoji huggers out there. I have a brother who absolutely loves emojis. I don't know where he finds them, but there's just tons of different ones out there. I never cease to be amazed at how much time he spends finding and using these emojis. So let's enter into part one. So how do humans communicate with machines, or put a different way, how do people talk to devices? One of the best ways to proceed with this is to look at the differences and the similarities between people and devices. So let's look at the differences first. So one of the differences, the stark differences between computers and ourselves, is that we communicate primarily with words, images, gestures, and things like facial expressions. I like to tell the story of the young mother with a 4-year-old daughter, and she's just made her dinner and put it in front of her, and the 4-year-old frowns and looks at her food and growls, and her mother, with saintly patience, says, "Use your words," to which she responds, "Damn it!" Well, that's what we do. We communicate primarily with words. Computers don't understand words. They don't care about our words. They only understand things like binary, Boolean expressions, digital information, and ultimately numeric data strands, which we're going to take a closer look at here in just a minute. Fortunately, there's also some similarities between humans and devices. Just as we are each unique, networked computers and devices must be unique. They don't necessarily have to be unique if they're not networked, but in order for them to communicate to each other, they have to be unique. Another similarity is that we both must have a physical address and a quote-unquote mailing address in order to communicate over long distances. And again, we'll see more about that as we continue. So let's take a closer look at what these data strands are made of. Again, I'm not going to go too deep in this, but I feel that this is important for us to look at this in order for us to understand a little bit more about how these data strands and these data communication takes place. So A bit is a binary 0 or 1, or a Boolean false or true, or a digital on-off. Now, if you're a computer code, the terms are typically, they're different, but they're used interchangeably in the computer industry. If you're a computer coder, you're probably going to speak binary. If you are a lawyer, you're more concerned about Boolean expressions, true and false. If you're a technician, electrician, or HVAC technician, you're probably going to concern yourself more with ons and offs. But essentially, the three terms are used interchangeably in the industry. A byte is 8 bits, and that's represented here on the slide. Now, when you think about a byte of information, think about individual letters. So the byte that we're looking at right now might represent the letter A. Now, simply by changing one of the ones or one of the O's in that byte, it might represent the letter B, and so on and so forth. So a string of bytes or data strands makes a packet. When you think about packets, think rather than individual letters, we put the letters together to represent names and words and places. That's a packet. And finally, a group of packets makes a data message or a data stream. Data streams are the full sentences. Even weaving the data streams together would be equivalent to our paragraphs, and paragraphs grow into chapters, and chapters grow into books. So you can see that once you're at the data stream point, you can move a lot of information around. So essentially, what we see here is if you have two devices that need to communicate with each other, they are basically just routing packets. In this instance, it is routed, rather than being routed directly from computer to computer, it's routed through a router to the internet, back to another router, and back and forth between the computers. Now, you can have individual devices directly connected to each other without the internet, but in this application, you can see that the packets of information are sent back and forth between two computers using the internet. Now, let's take a closer look at computer addresses. Again, we said that one of the things that's in common between computers and people is that we have to have a physical address and there has to be a network address. In computers, the physical address is called the MAC address. MAC address stands for Media Access Control. Again, think of this as being equivalent to either our passport number, which has to be unique, we're the only one in the world with that number, or a social security number, again, being absolutely unique. But to be able to communicate over a network, we also need a network address. Network addresses are exposed by identifiers called IP addresses. IP stands for Internet Protocol. Again, think of that as being analogous to a post office box or a street address. So we need to have a physical address and a network address. Let's take a closer look at the physical address. Again, the MAC address, or the Media Access Control address, it's made up of 6 separate hexadecimal numbers. Now again, we're not going to go too deep into this, but one of the advantages of a hexadecimal number over a decimal number is that you're not just limited to 9 characters before you have to jump to the next section. It's the numbers 1 through 10 plus the letters A through F, which gives us a total of 256 possible decimal numbers. So in the example down in the lower right hand, you can see that if you see a hexadecimal FF, that's equivalent to the decimal number 256. Now, let's take a closer look at network addresses. So again, computers think with regard to numbers and digital information. They don't really care about words. So when the internet first was originated, they realized that they needed to have a protocol for developing and working with these network addresses. Now, I don't know what happened to Internet Protocol versions 1 through 3, but for many, many years now, we have utilized Internet version IP version 4. Now, you'll notice from the slide that the total possible addresses capable under IPv4 is 4.3 billion possible addresses. Now, in the early days in computers, they couldn't imagine that there would ever need to be any more than 4.3 billion possible addresses. Well, within the last few years, they've come to realize that we could very easily overcome that 4.3 billion possible addresses. And again, these addresses have to be unique and individual. So they came up with IP version 6. IV version 4 uses 4 bytes. IV version 6 uses 128 bytes, which causes the range to grow into 340 undecillion possible addresses, basically infinity. For the purposes of this course, we are only going to concern ourselves with IPv version 4. And IPv version 4 uses 4 octets that are in the range of 1 to 255. So the address that we see up here is this unique IP address is going to be 172.16.254.1. Here's a good analogy for understanding how these work. And again, the analogy breaks down, so if you're a computer geek, you might balk at the way that I've chosen to illustrate this, but the general principle does apply. So we think about the need for Farmer Fred to have his own address. So with Farmer Fred, we're going to look at P.O. Box 777, Fairhaven, Washington 98656. Now, the IP address would, in order to equate that, we have to reverse Fred's address. But essentially, you can see from the IPv4 address that the 172 relates to the overall region, similar to the zip code. The second quadrant relates to the state, the third, the city, and the fourth defines the individual street or the individual box number. So you can see how these 4 octets allow you to be able to establish a wide range on down to a narrow range within that IPv4 address. So the question becomes, who assigns and manages these network IP addresses? Well, there's 2 choices. It can either be self-assigned, or what we call a static IP address, or it can be automatically assigned, DHCP, and we'll explain what that means here in just a minute. So the self-assigned static address, if you're only needing to talk from your computer to your printer, 2 digital devices, you really don't have to have them automatically assigned. You can actually go in and manually assign an address to the computer and a different address to the printer and have those 2 devices be capable of talking to each other. Sometimes local HVAC control networks can utilize self-assigned or static IP addresses. These require self-management. That's one of the biggest drawbacks. If you're not careful, you can have 2 addresses that are the same, and essentially what you have is an IP conflict in which the network is incapable of communicating with those 2 devices, because it would be equivalent to having you and your next door neighbor have the same post office delivery address. It's going to confuse things that go out, and it's going to confuse things that come in. So the other scheme is the automatically assigned. DHCP stands for Dynamic Host Configuration Protocol. Anytime you have multiple devices, there's a real advantage to using the dynamically assigned host configuration protocol because it's automatically managed. You don't have to worry about determining what your personal IP address is or setting that IP address. It's automatically assigned. So let's take a closer look at DHCP. Now, as you look at the slide here, I want you to notice especially that the key ingredient here is that there has to be a DHCP server. The DHCP server, even though it's called a server, it's actually the one that manages and maintains a pool of assignable IP addresses, and then it manages how it addresses the individual computers. Now, if you notice down below, the DHCP server, you have 4 computers there, 4 computer terminals, and each one has been assigned or leased a separate address, 21, 22, 23, and 24. The printer, however, has been given a reserved or a permanent lease, if you will, on its address because it can't change. Every time you unplug a printer and plug a printer back in, it needs to be addressed at the same address location. So it's just simply the DHCP server just simply gives it a permanent lease. And that basically sets it up more or less as a static IP. But the computers can come and go. They're assigned a lease by the DHCP server for a set amount of time. If you disconnect your computer and come back after the lease is expired, you may not be assigned address number 21. You might, the next time around, you might be assigned address 22 or 28 or whatever it might be. So what this does, the main thing that this does is it eliminates any possibility of having IP conflicts, helps the system run much smoother. Now, again, back to the problem that we talked about, and that is that we primarily communicate with words. Can you imagine, looking back at the previous slide, can you imagine if we had to memorize the IP addresses, especially if those IP addresses tend to change with the lease expirations? It would be an insurmountable problem. Computers only understand binary and numeric data. They don't care about words. So the solution was to come up with what are called DNS servers. DNS stands for darn near super. Actually, it doesn't stand for darn near super, but it is. It is almost darn near super what it does. It stands for Domain Name System. So basically, what a DNS server does is it takes a IP address, whether it's IPv4 or IPv6, and it associates it permanently with a domain name, which is a word or a series of words that we can identify with and we can understand. Words like google.com. So we don't have to know what the IP address is that is associated with google.com, but we do know that the DNS server has taken and assigned a specific IP address, a public IP address, and associated it with a specific domain name. It meets the need of both computers and humans. And there's a multitude of DNS servers. So there's a tremendous amount of redundancy. It's literally worldwide in terms of the servers. And you have virtually unlimited number of names that can be assigned. So the next question that becomes, how do I discover what my name is or what my device name is? And the answer to that is to use the command prompt diagnostics shell. Now, we are primarily, and throughout this series, going to be using Windows-based computers, but you can also do some of this on a Mac or a Linux computer. There's a few differences in how you get to the command terminal, but essentially we're going to be focusing on the Windows command prompt. Command prompts, there's a ton of different command prompts. I encourage you to Google it, further look into it. But primarily, as we work with technicians, we have 2 specific commands that we use that help us to do things like discovering our computer name and discovering the names of other computers and discovering what those DNS names are and what those IP addresses are. Okay, so because this is presented to you in a video format and not a live format, every time we go and do some hands-on exercises, I don't know whether you have one monitor or you have two monitors. Assuming that you have two monitors, I would encourage you to keep the video going, but initiate your command prompt in a separate screen. If you only have one computer or one monitor, I would encourage you at this point to write down what you're being asked to do in the seminar, and then pause the video in the seminar and go and do this exercise on your own, and then return back to the video. So from your Windows computer, you go to the Start menu. In the search box, type CMD, and it's going to come up in the search box Command EXE. Go ahead and launch that command. And when you do that, you're going to end up with a screen that looks like this. The next thing that we're going to do is we're going to discover what my name or what my device's name is. So I want you to go to the command prompt and type in the command name, host name. So I'm just going to do that real quick myself right now. And you can see that my host name has come up with JV Laptop 1. Obviously your host name is going to be different, but that is the name of your device. You may want to write that down because that will come up later on in the seminar as well. So the next question is, now that I know what my host name is, what is my IP address? So in this exercise, and again, you may need to pause the video, or possibly you can keep going and just do this alongside with me doing it. You need to enable your Wi-Fi if it hasn't already been enabled. You need to connect to a local Wi-Fi network. And if there is no Wi-Fi network, you may be able to connect, or you may already be connected to your hardwired Ethernet port and an Ethernet router. Hopefully you'll have internet access, but that's not essential if you don't. Now, at this time, you want to go back to your command prompt, and you want to type in the word ipconfig space /all. If you're a Mac user, it's ifconfig. And this is essentially what you're going to see. Now, I'm going to go do this on my live screen so that it shows up on the overall screen. Now, depending on how many network connections your computer has, you may only end up with a wireless LAN Wi-Fi and your Ethernet connection. If you have VPNs or other network connections, you could end up like I do with a whole list of these things. So you can scroll up and down. Now, the thing that we want to focus in on here is we want to find the wireless LAN adapter or Wi-Fi. So I'm going to scroll down to the Wi-Fi. And these are the things that I want you to notice here. Look at what you're being told in this column here. Remember that every device has to have a fixed physical address, which we see here. This tells us whether or not the DHCP feature on the device has been enabled, or whether it's using a static IP address. If DHCP is enabled, then the DHCP server is able to grant leases and release those leases or expire those leases of the individual computers that are connected to the network. So you notice that you even have that information here. The biggest thing that we're concerned with, we've asked the question, what is my IP address? you want to look at the IPv4 address here. You can see that in this case, we've been assigned 192.168.0.53. That was assigned to me when I connected my laptop to the current Wi-Fi network that I'm connected to. Notice that the DHCP server leased this connection to me at such and such a date and time, and that lease expires, in this case, just after a few hours on the same day. Now, some DHCP servers have different lease expiration times. So essentially, if I came back tomorrow and tied into this Wi-Fi network again, there's a very good chance that it's not going to give me address 53. It may give me a different address because my lease will have expired. So essentially, there's other information here that we won't get into, but this tells you as a technician a lot of information about what your computer is doing in order to fulfill its requirements to be able to communicate with other computers. Now back to the PowerPoint. How do I verify that I can talk to another device? Well, for that, we're going to play a game of ping pong. Now, if you remember actually playing the game of Pong on a computer, you probably have as much or more gray hair than I have because it's been around for a long, long time. But essentially, the IT people utilize a ping pong game to determine whether or not you're able to communicate to another device. And so they use the command prompt of ping to go out and ping another device. So, you ready for another live exercise? Here we go. Open your command prompt shell. Once again, type in ipconfig. Notice that I'm not typing in ipconfig all, so you're going to get a less detailed list of IP addresses there. Probably just your Ethernet connection or your Wi-Fi connection is going to show up there. Note what your IP address is. Now, in this exercise, if you have internet access, I want you to type in 172.217.164.110. If you don't have internet, I want you to type in 127.0.0.1. Now, if you don't have internet access, what I'm actually doing there is I'm having you ping a loop back within your own device. So you're essentially pinging your own device, which would be akin to playing ping pong and lifting the side of the ping pong table up and literally playing against a wall or playing against an upright part. So you're echoing your ping pong ball back to you. So once you've done that ping, let's take a closer look at the anatomy of the response that you get. Notice that when you ping a device, it goes out and basically volleys up 4 serves. So you're going to get reply from, reply from, reply from, reply from 3 to 4 times typically when you ping a device. Now, let's look a little bit closer at the information that you get when you ping a device. The 32 bytes, think of that as being similar to the size of the ping pong ball or tennis ball if you're using a tennis analogy here. The time is really the most important aspect of this. The time is basically how long in milliseconds it takes for your data to go out and be ponged back by the other device and for you to get it back before you hit it again. So it's that time period that it takes for it to go out and return. TTL we're not concerned with at this point, but notice down below it's giving you some statistics. It's telling you how many packets were sent and how many were received and how many were lost. If you do find that you lose packets, it's probably because you have a poor connection. Typically, you should not lose any packets. It also gives you the minimum time that it took, the maximum time, and the average. In this case, the example that I've got right now is it's pinging a device that is extremely close. So 2 to 4 milliseconds is all the time that it's taking to be able to ping that device. Now, remember that we've already learned that if a DNS server is involved, that every IP address has an equivalent domain name. In this case, the device, the IP address that I had you ping is actually the IP address of google.com. So you can go back to your command prompt if you have access to the internet. You could go back to your command prompt and tell it to ping, and instead of entering the IP address, you could literally put in the domain name and ping it. Now, notice that I just went out and pinged google.com. It's telling me here that it's google.com, which the DNS server resolves it to this IP address. Nobody else has that IP address but google.com. Notice that it's taking me between 11 and 12 milliseconds to be able to send that ping out and get a response from Google. So obviously you can ping using a domain name instead of an IP address. Now here's kind of a fun example. Here I pinged the Chinese government, and notice that the time that it took to go to China and back is still pretty quick. It varied between 105 and 128 milliseconds. Now, you can actually diagnose potential problems with your network by looking at the ping time. So if the ping time is anywhere from 1 to 100 milliseconds, that's a really good connection. That's a good network speed. If it's between 100 and 300, that's okay. Truthfully, if it's over 500, you have some kind of connectivity issues or something is going on that is really compromising the communications in your network. So, how do I talk to another device if there is no router, no DHCP server, or no DNS server? Well, you have to establish a static IP address. Now, this, out of all of the IT skills for the HVAC educator and the HVAC or electrical industrial process controls technician, this is probably one of the most important things or skills that you need to learn. Again, you don't have to be an IT expert, but for us to be technicians working with direct digital controls, we have to know how to go into our manager and adjust from an automatic or a DHCP address to a static IP address. So how do we do that? Again, if you have the opportunity to, this is an exercise, so if you have the opportunity and need to pause this, write this down and pause, go ahead and do that. If not, just follow along with me. So in order to establish a static IP address, you need to do the following things. You need to open the control panel. You need to open network and sharing. You need to click on change adapter settings. You need to double click on the Ethernet connection. Click on the properties box. You need to highlight the Internet Protocol version 4 or IPv4 settings. And that's going to take you to this pop-up. And you're going to need to uncheck the obtain IP address automatically and check the use the following IP address, and then you're going to enter the appropriate IP address that you need to set up as a static IP address. Now, I'm going to go ahead and demonstrate that by doing that very thing. So I'm going to go to my Start menu, my control panel, my network and sharing center. I'm going to change adapter settings. And again, you may not have this many network connections, but I'm going to open the, if I need to set a static IP address, let's say on my standard Ethernet port, I'll select that. I'm going to scroll down to the IPv4 and highlight that and bring up properties, or I can double click on that. Now you notice that right now it's set to DHCP, or obtain an IP address automatically. To set a static IP address, I simply hit the bullet and populate this. Now, I'm not going to do that right now, because if I do set a static IP address, I'm going to lose my connection with the internet. So, and I would encourage you not to do that at this point either, or you will lose your video feed. So that is how we set a static IP address. When you're done using the static IP address, let's say you're out on a job site and you need to connect to a DDC controller on an air handler. You may have to set your computer up with an IP address that is within the fixed range of that controller. That's when you would need to set a static IP address. But before you go back to the office and plug your computer back in or acquire a Wi-Fi signal in your office, you're going to have to reset it back to obtain an IP address automatically, so that the DHCP server then controls your addressing. So that takes us to the end of part 1, how do humans communicate with devices. So just to recap, the most important takeaways here is to remember that every single computer or DDC device requires both a physical address, which we call a MAC address, and a network address, which we call an IP address. It's important for us to realize what the role of a DHCP server is in terms of establishing automatic addresses in order to eliminate the possibility of having IP conflicts or two or more devices assigned to the same address. It's important to understand what is going on in terms of a domain name system and how that helps us as people to translate words into what computers need, which is numbers. And finally, probably most importantly, is the use of the command prompts ipconfig and ping, and the ability to set a static IP when you need a static IP in your computer and turn it back over to a DHCP server. So thank you for joining us for part 1 of this series. We'll see you back after the break for part 2. Thank you.